Welcome to my channel. This is Franco Pantaleon. In this video, we will tackle arithmetic sequence, arithmetic means, and nth terms. So we have this sample arithmetic sequence, otherwise known as arithmetic progression. So we have here the arithmetic sequence 2, 5, 8, 11, 14. Notice that we have a common difference between 2 and 5, which is 3. 5 minus 2 is equals to 3. 8 minus 5 is equals to 3. 11 minus 8 is equals to 3. And 14 minus 11 is equals to 3. The common difference is equals to 3. A1 being equal to 2, or A2 is equals to, we have 2 plus the difference 3 equals to 5. So it's similar here. We have this expression. This is our A2. And our A3 is equal to, we have A1 plus 3 plus 3. So we have 2D, A1 plus 2D. So our A3 is equals to A1 plus 2D. So we now have this corresponding pattern. As you can see, our A4, if we are going to continue, we have A1 is, or A4 is equal to A1 plus 3D. So we have a common pattern here. So these are the corresponding formulas often useful when it comes to problems involving arithmetic sequences. So we have this formula to find the nth term. We have our nth term is equals to E sub n equal to A1 plus n minus 1 times d. And for arithmetic means, suppose we have two numbers a and b there, then their arithmetic mean would be equal to a plus b over 2, since we only have two numbers. Then another probably useful formula would be also this nth partial sum of arithmetic sequence, which is equal to S sub n is equals to n over 2 times a1 plus a sub n. So let's have some illustrative examples. So what is the 10th term of the following arithmetic sequence? Negative 5, negative 1, 3, 7, and 11. Notice here that these have a common difference of 11 minus 7 is equals to 4. 7 minus 3 is equals to 4. And this also have a common difference of 4. And this have also a common difference of 4. So we can see that our D is equals to 4. And our first term is equal to negative 5. To determine the nth term, we can simply use the formula. an is equals to a1 plus n minus 1 times d. So we can have our 10th term is equals to a1 plus our n is equal to 10 minus 1 times d. Since we already have values for our a1, we have our a10. Our nth term is equals to negative 5 plus, we have 10 minus 1 times d, which is equal to, the common difference is 4. Okay, then simplifying this further, we have our a sub 10. The 10th term is equals to 31. This is our answer. Another illustrative example, we have insert 2 arithmetic means between square root of 2 and 4 square root of 2. Determine the first arithmetic mean. Okay, let us write our numbers. So we have square root of 2 and we have 4 square root of 2. And we are required to insert 2 arithmetic means. We may insert these two arithmetic means C1 and C2. And to determine our number of terms, this is our first term, second term, third term, and our fourth term. Okay, we can use our equation. We have a sub n is equal to a sub 1 plus n minus 1 times d. So this is our a1, and this is our a, the fourth term. So we can write this equation as en is 4 square root of 2. We have a4. a4 is equals to a1 plus 4 minus 1 times d. So our fourth term is equals to 4 square root of 2 is equals to our a1 is equals to square root of 2 plus we have 4 minus 1 times d. Our only unknown is d. So this simplifies to 4 square root of 2 minus square root of 2 which is equals to 3 square root of 2. 4 minus 1 equals to 3. So we have 3d. Our d is equals to square root of 2. And our first arithmetic mean would be equal to, simply equal to the first term which is a1 plus the common difference which is square root of 2. Therefore, our c1 is equal to our a1 plus our common difference. Our c1 is simply equal to square root of 2 plus square root of 2. Therefore, our c1 is simply equal to 2 square root of 2. So this is our first arithmetic mean that we can insert between 2 square root of 2 and 4 square root of 2. So this is our answer. Another illustrative example, we have a sub, the first a1 is equals to negative 4 and the 25th term is equals to negative 100. We are required to find the 100th term. So given this information, and this information, we can target to solve for d. So we have an is equal to a1 plus n minus 1 times d. an for the 25th term, a25 is equals to, our a1 is negative 4, 25 minus 1 times d. And since we already have the value for the 25th term, we have this equation. Negative 100 is equals to negative, this is plus by the way, negative 4 plus 24 d. Our only unknown is d. So if we simplify this further, our d would be equal to, our d is equals to negative 4. Having known for negative d, our d is equals to negative 4, we can now find our 100th term. So our 100th term is equals to a1 plus 100 minus 1 times d. Of course, we already know our a1 and our d. Therefore, we can readily determine our 100th term. So we have the 100th term is equal to, a1 is equals to negative 4 plus 100 minus 1 times the d is equal to negative 4. And our 100 term is equals to negative 400. And this is our answer. So let's have another illustrative example. If the third term is equal to 8 and the 16th term is equal to 47 and a sub k is the kth term of the sequences and a sub k is equal to 212, then what is the value of k? So this is quite tricky problem. Anyway, so if we will simply write our a1, our a2, and a3. a3 we have known our a3, which is equal to 8. Likewise, we also have known our 16th term. Our 16th term is equals to 47. And our AK is equals to 212. Now, if this is an arithmetic sequence, then our A2 must be equal to A3 minus the common difference, since this is our reference number. Then our A1 is simply equal to A3 minus 2D. Okay. So this is a very, very important expression. Our A1 is equals to A3 minus 2D. Now, take note that we are given our 16th term, which is equals to 47. We will use this information here. So we have our AN is equals to A1 plus n minus 1 times D. Our the 16th term is equal to our A1 is equal to this. Our A1 is equal to A3 minus 2D plus 16 minus 1 times D. And by the way, guys, since we already have known our A16 and E3, we have values for A16 and A3, then the only unknown is D. We can now solve for the common difference. So this is 47 is equals to 8 minus 2D plus we have 15D. Solving for D, we have solving for D, we have this 15D minus D, we have 13D. 13D is equal to 47 minus 8 equals to 39. Our D is equal to 3. Okay, since we already have known our D, we can now determine our K given this information here. So our AK is equal to A1 plus K minus 1 times D, which is similar to this equation here. So our AK is 2, 1i. Let me erase this first. Okay, AK is 212 is equals to our A1. Our A1 is equals to A1 So our A1, by the way, our D. So let us first solve for our A1. Our A1 is equal to A3. Our A3 is equals to 8 minus 2 times 3. Our A1 is equals to 2. Okay, so let us substitute this value here. 2 plus K minus 1 times the common difference is 3. Our only unknown is K. Therefore, we can solve for our K. Simplifying this expression and solving for K, we have K is equals to 17. K is equals to 17. So this is our answer. Next example. Insert two arithmetic means between 3 and 30. So let us write our arithmetic sequence. So we have 3 and 30, and we are required to insert two arithmetic means, C1, C2. Okay, so our number of terms are 1, 2, 3, 4. Now we know our fourth term, so again we'll use this formula. En is equals to A1 plus n minus 1 times D. En or A30. A4 is equals to A1 plus 4 minus 1 times D. So substituting the known values, we have 30 is equal to 3 plus 4 minus 1 is equals to 3D. Solving for D, 30 minus 3 is 27. 27 divided by 3 equal to 9. Our D is equal to, our D should be equal to 9. So we now have known our D. Therefore, our difference is equal to, common difference equal to 9. 9. Okay. And 9. So, our C1 is equals to 3 plus 9 is equal to 12. Our C2 is equals to, we have 12 plus 9 is equal to 21. Okay. So, to complete our arithmetic progression or sequence, we have 3, 12, 21, and 30. And notice that the common difference is 9. 3 plus 9 equals 12. 12 plus 9, 21. 21 plus 9 equals to 30. So, this is our answer. 12 and 21. Next illustrative example. After 1 second, a rocket is 30 feet above the ground. After another second, it is 85 feet above the ground. Then after another second, it is already 140 feet above the ground. If it continues to rise at this rate, how many feet above the ground will the rocket be after 16 seconds? So, we're given the time in seconds. After 1 second, and the distance, after 1 second, the distance is 30. Okay, after another second, the distance is 85. After another second, the distance is 140. So you notice we have 85 minus 30 is equals to 55. 140 minus 85 is equals to 55. So we have a common difference is equals to 55. Since we are required to determine our 16th term, this is simply equal to A1 plus 16 minus 1 times D. So since we already have this D, we have our A1, which is 30. We can readily determine our D. Our A16 is equal to A1 is 30 plus 15 times 55. Our 16th term is equal to 855 feet, and this is our answer. 855 feet. Okay. The last but not the least illustrative example. An object is dropped from a plane and falls 32 feet during the first second. Again, we have this time in seconds, and we have this distance. So first second, we have 32 feet. For each succeeding second, it falls 40 feet more than the distance covered in the preceding second. How far has it fallen after 11 seconds? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Anyway, we have plus 40. We have a common difference is 40. So 32 plus 40 is equals to 72. 72 plus 40 is equals to 112. 112 plus 40 is equals to 152. 152 plus 40 is equals to 192. 192 plus 40 is equals to 232. Anyway, we have this. We can solve the problem using this method. However, we will use the formula for us to solve faster. Our 11th term is simply equal to our A1 plus n minus 1 times D. And by the way, the common difference is 40. Our 11th term is A11 is equals to our A1 is 32. Which we have 11 minus 1 with the common difference of 40. Our A11, the 11th term is equals to 432. I will just complete this tabulation here so that everything will be clear. So we have 232. By the way, this is 11 is 432. 232 plus 40, we have 272. 272 plus 40, 312. 312 plus 40, 352. 352 plus 40 is 392. So guys, this is our answer. And as you can see, it is very clear that after 11 seconds, it has fallen 432 feet. I hope this clarifies everything. Okay, so that's it. If you like the content of this video, click like and subscribe, and please share. Thank you.